All right, so today we're doing Unit 2, Day 2, which is special right triangles. And you might remember this topic from geometry. So this could be a possible review topic. But we're on page 11 in your trig booklet. I want you to refer back to this diagram. And then also you can add on there that we're talking about 45, 45, 90 triangles. So a lot of times I write it out as 45, 45, 90. And across from a 45-degree angle is an N. These are both the same because it's isosceles, right? It's an isosceles triangle. So I'm going to put N, N, and across from the 90 is your N root 2. So I might refer back to this occasionally. And for 30, 60, 90 triangles, that's your other special right triangle. Across from the 30 is N, across from the 60 is N root 3, and across from the 90 is 2N. So again, I might set it up like that when we do the example problems. Okay, so turn to page 12, and we're going to go through the in-class part, and you can follow along. All right, so first off, on number 1, we want to know what is the type of triangle that we're looking at. Since they give us a 45-degree angle, we know we're for sure talking about a 45, 45, 90 triangle, because we've got a 45 and 90, so the other angle must be 45. All right, so we're going to set this up. We've got 45, 45, 90, and we need to find the missing sides. So we know that this should be N, N, and root 2. What do they give us? They give us that the side across from the 45 is 14. So then these should just match up. So my N is equal to 14. That means that this N also has to be 14, and this N needs to be 14. So this last side is 14 root 2. So the one that's across from the 45 is 14. That's one answer. The one that's across from the 90 is 14 radical 2. Okay, so all you're doing is finding the missing sides. So just to make this a little bit easier, we're going to do all the 45, 45, 90 ones first, and then we're going to come back to the 30, 60, 90s. All right, so let's look at problem number 3. This is a 45-degree angle, so I know that this angle has to be 45 degrees. So I'm just going to set up my generic formula. It's always N, N, and root 2. All right, so let's see which one did they give us. Here's my 90-degree angle, so they gave me the one that's across from the 90-degree angle. This is 13 root 2. So if N root 2 is equal to 13 root 2, then N has to be 13. So this N also has to be 13, and this N has to be 13. So that means that the side across from the 45 is 13. The side across from the other 45 is also 13. Then you're all done. All right, number 5, also a 45, 45, 90 triangle. So we're going to use the same formula. We have N, N, and root 2. All right, so let's look at what's given to us. We have 90 degrees. Across from the 90 degrees is 14. Now this one's a little bit weird. You're going to have to do a little bit of work. So it's supposed to have a radical 2 next to it, but it doesn't. Okay, so I'm going to set up an equation. N root 2 is supposed to be equal to 14. So we can just solve this equation. How do we get N by itself? Well, these are being multiplied, so to undo multiplication, we're going to divide both sides by root 2. So that would be my answer. N is equal to 14 root 2. However, I don't want to leave a radical in the denominator. So remember from the last couple days, if we want to rationalize, you multiply by root 2 on the top and bottom. So you get 14 root 2 over 2. And then 14 over 2 is really 7. So this tells me that the value of N is equal to 7 root 2. So going back to my generic formula, the value of N should be 7 root 2, and the value of N should also be 7 root 2. Okay, so that tells me that this side should be 7 root 2. This side is also 7 root 2. So problem number 5 is going to be like the hardest type of problem, where it's supposed to have a radical, but it doesn't. So you just have to write a little equation, and I think you can solve a one-step equation. All right, so let's go to the ones that have 30, 60, 90 triangles. All right, so let's go back to this formula. All right, so we've got 30, 60, 90. So we're going to just write down 30, 60, 90, and we have N, N root 3, and 2N. All right, so they give us the side that's across from the 30-degree angle. So that's my N. So I'm going to put 9 here. All right, now anytime in my formula, I can fill in n to be 9. So if n is 9, this should be 9 root 3. This should be 2 times 9, which a better way to say that would be 18. So that tells me that across from 60 is n root 3. Across from 90 is 18. Okay, so we're going to continue with our 30, 60, 90. So we're going to use the same formula. 30, 60, 90 should be n root 3, and 2n. Okay, so which one do they give us? They give us the side that's across from the 90. So across from the 90 is 12. All right, maybe it helps you to write a little formula. 2n should be equal to 12. So if I divide both sides by 2, that tells me that n is 6. Okay, so everywhere I see an n, I'm going to replace with a 6. So that's 6. This is 6 radical 3. That tells me that across from the 30, we have 6. Across from my 60, we have 6 radical 3. All right, and then one more 30, 60, 90 triangle. So we've got 30, 60, 90 should be n root 3, and 2n. Okay, so which is the one that they give us? They give us that the one across from 60 is equal to 9. So this is where you probably want to write a little equation. N root 3 is equal to n root 3 is equal to 9. So to get n by itself, I want to divide by that radical. And I could leave my answer like this, but it's not proper form, so I'm going to multiply by root 3. I get 9 root 3 over 3, which reduces 9 over 3 is 3 root 3. So that tells me the value of n. So everywhere I see an n, I could put in 3 root 3. Here I have 2 times 3 root 3. And then if you remember from the other day, if you're going to multiply the coefficients, so this is 6 root 3. That tells me across from the 30, I've got 3 root 3 as my side. And across from my 90, I've got 6 root 3 as my side. All right, last problem. Number 7 says, find the exact value of each trig ratio. Do not use a calculator. All right, so cosine of 45, we're going to refer back to our special right triangle here. All right, so I'm just going to redraw this diagram. In a 45-degree triangle, I have n root 2. So now let's think about what our SOHCAHTOA told us from yesterday. Cosine is equal to the adjacent over the hypotenuse, because A and H stand for adjacent and hypotenuse. All right, so let's put theta by one of your 45-degree angles. It doesn't matter which one. I need my adjacent side, and I need my hypotenuse. And you're just going to make a ratio. So cosine of 45 is equal to n over n root 2. Now, to simplify, if I've got the same thing on the top and the bottom, my n's can cancel. So really, I've got 1 over radical 2. That answer would be okay, except I've got a radical in the denominator. So I'm going to multiply by radical 2. So now I have 1 root 2 over 2. And so the value of cosine of 45 is always going to be 1 root 2 over 2. All right, last one. We're going to do secant of 30. So I'm going to copy my diagram. We've got 30. Across from there is n. N root 3 is across from the 60. And 2n is across from my 90. So if I want secant of 30, I'm going to put my theta at the 30. Secant, if you recall, is the reciprocal of cosine. So this should be hypotenuse over adjacent. So let's find out which one's our hypotenuse, which one's our adjacent. So we've got 2n divided by n root 3. And then if you see the same thing on the top and the bottom, so these two n's can cancel, so I'm left with 2 over root 3. But I don't want to leave my answer like that because there's a radical in the denominator. So I'm going to say 2 root 3 over 3. And then I'm all done.